Here's Aji with your number 11 from the summer Toffee packet.
Wow! Number 11 describes a projectile being thrown at an angle of 23 degrees with an initial velocity that's given to you. It's being thrown at a truck that starts in a position of 45 meters and is proceeding onward at a speed of 15 meters per second. Now we're tasked with finding exactly where this ball is going to touch the back of the truck. And so, given this information, we start by looking at the velocity of the truck in the x direction. Its position can be tracked by multiplying its velocity by its time and adding the initial position. Similarly, the projectile can be tracked in the x direction using the equation position is equal to v initial cosine theta, v initial in it being given to us as 35 meters per second, and theta being given as 23. And time is multiplied to that. It's right here, even though it's not right here. Now setting these two equal to each other shows us when the x position of the projectile is equal to the x position of the truck. Now setting them equal, we attain a time of 2.614 seconds, which is the answer to the first part. The second part asks what will happen if the truck is only 2.0 meters tall. For the first part, examines an infinitely tall truck and we run into no power. Now the projectile can be tracked along the x-axis using the same equation as before, 32.22 times t, and along the y-axis we use the projectile motion equation 1/2 gt squared plus v initial sine theta t plus 0, the initial position of the projectile. So tracking it along both axes, we find that at the time of 2.614, the y position of the projectile is 2.25 meters high, which is a quarter of a meter too high to touch the back of the truck. After crying over this, we attempt to find out what happens shortly afterwards. Will it touch the top of the truck? Will it go over the truck entirely? No, because the truck is infinitely long in this problem. So we try to find that distance because it gives us some semblance of meaning in our lives. So by multiplying the difference between velocities of the projectile and the truck in the small period between when it goes over the back of the truck and when it touches the top of the truck, by the time spent in that little interval, we find that the ball touches the top of the truck 36 centimeters geographically after the back of the truck.